So here everyone listen about some important notes about photoelectric effect. So from the Holmes and Lennard observation, what we understood? Now we understood that when UV light fell on the emitter plate, no electrons are emitted at all when the frequency of incident light was smaller than a certain minimum value called threshold frequency. Remember. So here we understood that the emission of photo electrons basically depends what basically here? That depends on some minimum frequency of light. That is called basically threshold frequency or nu naught. Okay. Below this no photoelectrons will emit. Above this only electrons will emit. So some threshold frequency, some existence of threshold frequency understood from the experimental observations. Okay. Now next, this minimum frequency, threshold frequency depends on the nature of material of the emitter plate. That means whatever emitter plate we have taken, okay, from where electrons are emitting, now it will fall light on that. So for all light it will not emit electron. It will emit light if its frequency, that incident frequency is greater than nu naught, then only it will emit light. So that type of conclusion we are getting here. Okay. Now next, so existence of threshold frequency is coming. We'll define what is threshold frequency. Okay. In these points we'll decide, important notes we'll discuss. Okay. Now next listen. It was found that certain metals like zinc, cadmium, magnesium, etc. respond to UV light. Okay, they responded to UV light. That means on UV light their photo electrons are emitting. So UV lights of short wavelengths to cause electron emission from the surface of metal. So that means zinc, cadmium, magnesium, they are sensitive to UV light. Similar way, some alkali metals like lithium, sodium, potassium, everything remember, lithium symbol Li, sodium Na, potassium K, cesium Cs, and rubidium are sensitive to visible light. Rubidium, lithium, sodium, potassium, cesium are sensitive to which light? Visible light. So this is the observation we got from the experiment. Yes or no? So tell me which materials are or metals are basically sensitive to UV light? Zinc, cadmium, magnesium. And alkali metals like lithium, sodium, potassium, rubidium, cesium, they are sensitive to visible light. Okay. So 3 points we completed on important notes. Okay. Now remember this. Now next points we listen. Work function. Let me explain. After that you write. Work function. So what is work function? Now work function symbol is given as a phi naught. Listen all of you. Definition will come in exam, board exam also. So the minimum energy required by an electron to escape from the metal surface is called work function. So what is the work function? It is a minimum amount of energy required to remove one electron from the metal surface. Symbol is given as a phi naught. So this is energy basically, minimum energy. Unit will be electron volt or joule, like that. So phi naught is nothing but symbol is h into nu naught. Nu naught already I told, threshold frequency, again definition also will discuss. And that is also can be written as hc by lambda naught. All of you listen. Work function is what? It is energy. It is basically minimum energy or minimum amount of energy or minimum energy required by an electron to escape from the metal surface. Phi naught is h nu naught. Nu naught is threshold frequency, and you know frequency can be written as speed of light divided by wavelength. Speed by wavelength. So c is speed of light by lambda naught. Lambda naught is what? Now that is the threshold wavelength. Here it is written 6th point, threshold wavelength, and this here nu naught is threshold frequency. Okay. So these 3 definitions very important you have to remember. So remember here this one. And what will be SI unit? Now SI unit of phi. SI unit of phi is joule basically. It is energy na. So energy means joule. Phi naught is basically joule. So that one you remember. Sometimes in electron volt also you can represent. And there is a relation also between electron volt and the joule. You know, 1 electron volt equal to 1.6 into 10 to the minus 19 joule. Okay. Now remember, work function phi naught depends on the properties of the metal and the nature of its surface. Work function depends on what? Properties of metal and nature of its surface. And the work function of platinum is highest. Remember, for platinum material, work function is highest, while it is lowest for cesium. Okay, 2.14 electron volt for cesium, 5.65 electron volt for. I told electron volt also can be unit, practical unit for phi not. So platinum is highest work function, cesium is lowest. Now next step, 50 point, listen, threshold frequency. See, threshold frequency we told it is a minimum frequency. In the first point we discussed. So the minimum frequency below which, remember, minimum frequency below which no emission of photoelectrons takes place. Okay, that means if your incident frequency nu less than nu naught, no photo emission, no photo emission, no photo emission. Okay, if nu greater than nu naught, then only photo emission will happen, or photo current will become not equal to 0. So this is your photo current. Photo emission will happen, right? No, here no photo emission, no photo emission. Here photo emission is there. Photo emission. Okay. So here photo current nu greater than nu naught. Photo current not equal to 0. But here what happens? Photo current 0. So how much your intensity, it does not matter. Okay, if your frequency, incident frequency is less than nu naught, then what will happen? No photo emission, no photo emission. So that one you remember everyone, no photo emission. So this is about threshold frequency. What is threshold frequency? The minimum frequency below which, remember, minimum frequency below which no emission of photoelectron takes place. Remember everyone definition, the minimum frequency below which no emission of photoelectron takes place. Now next, threshold wavelength. What is threshold wavelength? That is a maximum wavelength. See, you know, frequency and wavelength are inverse proportional. Here you can check here, inverse proportional, inversely. So if it is minimum frequency, threshold frequency, then maximum wavelength will be threshold wavelength. So maximum wavelength, wording remember, above which no emission of photoelectrons takes place. That means if incident wavelength lambda is greater than lambda naught, no emission. So I can write here, if lambda is greater than lambda naught, then no emission, no photo emission. You can write no photo emission, no photo emission, no photo emission. So remember what is threshold wavelength? The maximum wavelength above which no emission of photoelectrons takes place is called threshold wavelength. Is called what? Threshold wavelength. Okay. For threshold frequency, it is minimum frequency below which no emission of photoelectron. But for threshold wavelength, the maximum wavelength above which no emission of photoelectrons takes place. Clear idea? So these three definitions you must remember. Okay, three definitions. So now next point, remember here. This is last point, up to 9 last point, remember. Now 7th one is what? 7th one is no 1 electron volt. 1 electron volt is the energy gained by an electron when it has been accelerated by a potential difference of 1 volt. And remember, 1 electron volt is 1.602 or 1.6, usually can take into 10 to the power minus 19 joule. 19 joule. So remember this one. You want to convert to joule to electron volt to joule. With this relation you can convert. So remember everyone. Okay, last time one MCQ question also came in exam. 1 electron volt equal to what? How much? So 1.6 into 10 to the minus 19 joule. Okay. Electron charge na, this electron charge, volt is there. So charge into voltage is energy. So joule coming. Now that means what they are telling here. Now here if a potential is there, here positive potential, here negative potential. If electron is accelerated in 1 volt, potential, how much energy it will have, potential energy? Now that is QV, electron volt. Yes or no? It will have energy EV. So now selenium, next point, listen. Selenium is more sensitive than zinc or copper. So remember this also. Now next is UV light gives rise to photoelectric effect in a copper, while green or red lights. Remember, for copper which light? UV light. Okay, but for green or red light it does not give. So that also remember. So copper does not give photoelectric effect in green or red light. That means visible light. Green or red light means these are visible light. But copper gives for UV light. Are you getting or not? So this one you remember, 1 point. Okay. For green and red does not give. Now next point, another point I will tell, 10th one. All of you listen. Sometimes in calculation you need this HC value. HC. H is Planck's constant. C is speed of light. So if you will substitute the data, now you can substitute also. H sometimes it will be given 6.626 into 10 to the power how much? Who can say? Minus 34 joule into second. Joule into second. Similarly, C equal to how much you tell? 3 into 10 to the power 8 meter by second. Okay. Now remember everyone, FC equal to how much? SC is 1240 electron volt nanometer. 1240 electron volt nanometer. Okay, if H value, C value will multiply, you'll get this one. So I'm directly writing here 1240 electron volt nanometer, or SC also you can take as 12,400. 12,400. You can take that also. So here 1240, remember, here 1240, and here 12,400 electron volt angstrom, because you know 1 nanometer how many angstrom? 10 angstrom. So these values you can use, these values you can remember. Okay, if a angstrom or nanometer unit given, you can do that. Now all of you listen next. Energy in electron volt. If you want to find energy in electron volt, then suppose you have HC value here, HC value you have, then what you can do? Now you know E equal to HC by lambda, so you can write it is 1240 divided by lambda in nanometer. So whenever wavelength given in nanometer, if you want to find energy, you can use this relation. Okay, you can use this relation, or you can do 12,400 divided by wavelength in angstrom. You remember this, we'll use in problems. So all of you listen. SC value is 1240 electron volt nanometer. This 2 unit also remember. If energy in electron volt is there, then it will be 1240 by lambda in nanometer. Lambda will be in nanometer. Now here what is happening? Now here, if your lambda in angstrom it is there, in unit angstrom unit is given, then 12,400 you do. Otherwise you can multiply H and C value, but it will be little time taking, right? If you use this formula now, it will be little easy. Clear? So if energy want in electron volt, wavelength given in nanometer, then you can use this. If energy you want to find in electron volt, wavelength given in angstrom, then you can. Okay. So this is the idea you have to remember about what? About important notes about photoelectric effect. Okay. So which materials are giving photo emission for which type of radiation, that also remember, and what is 1 electron volt, and how to find that energy and all if a wavelength given in angstrom and nanometers. Clear idea? So this one you write down, note it down all of it. Okay, so I hope you understand everything. So please note it down everything.